Hello class, today we're going to look at factoring difference in sum of cubes, and the objective of the video is to learn how to use the difference in sum of cubes to factor and solve polynomials. Again, we're going to look at a couple of vocab terms to familiarize ourselves with the difference in sum of cubes. Okay, the vocab we want to look at, remember, is difference, which is we talked about in last night's video with subtraction or subtracting. The sum is addition or adding, and tonight we're going to talk about cubes. And a cube is a value found by multiplying a number by itself twice. So that would be like taking 3 and multiplying it by itself 2 times. Sorry. So 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. So we would say that 3 cubed is 27 and 2 cubed is 8. So these are cubes. Okay, and another thing I want y'all to remember is the quadratic formula, which is when we have a quadratic, something with the highest exponent of 2 written in standard form set equal to 0. If we cannot factor it, you can always solve it using the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to, just a little hint that we're going to have to use these when we're using the sum or difference of cubes to solve polynomials. So I want to make sure that you have this written down in your notes so that you can remember it. Okay, so when we have a difference of cubes, just like when we had a difference of squares last night, you're going to have a binomial, which is 2 terms, and then with those terms, both terms are going to be perfect cubes. So an example on this is the form you're going to memorize. When you have a difference of cubes, you have a cubed minus b cubed. Okay, where you have 2 of them. Okay, and so this is going to equal a minus b times a squared plus a times b plus b squared. Okay, so this is the formula for difference of cubes. Again, we have a difference problem that's being subtracted. I have 2 terms and they're both perfect cubes. So we will break this down to a minus b times a squared plus ab plus b squared. And then put a little asterisk here because you're going to need to memorize this. Okay, you're going to need to know how to break this down. So let's do an example. Let's say I had 8x cubed minus 1. Okay, so the first thing you want to know, we want to factor this. I have a difference, and you ask yourself, is a perfect square cubed? Is b a perfect cube? Okay, well I showed you all earlier that 2 cubed was 8. This is a perfect cube, and 1 is always a perfect square or perfect cube. So I can say, okay, my a is going to equal, what's the cubed root of 8? Well, 2 times 2 times 2 is 8, so a is going to equal 2, and then the cubed root of x is x cubed is x, and then b is going to equal just 1. So I can break this down and substitute what I know. I have a minus b, so this becomes 2x minus 1. Okay, using my a and b, I'm going to take a and square it, so 2x times 2x is 4x squared, and then a times b would be 2x times 1 would be plus 2x, and then square b would be plus 1. Okay, so now I have broken this down, my difference of squares, into 2 binomials. Okay, I cannot factor this anymore, but now I have this quadratic I need to factor. And that's when, if we set this equal to 0, you know how we want to solve. Okay, well I can try to factor this out, take 4 times 1 and then see if I can factor and break it down that way. But sometimes it's just easier to go ahead and use the quadratic formula. So I'm going to go ahead and set this factor equal to 0, 2x minus 1 equals 0, and add 1, I get 2x equals 1, divide by 2, and I have x equals 1/2. So that takes care of this one factor. So let's go ahead and see if I can factor this problem here. Okay, well if I try to factor this, I see that 4 times 1, I slide this down and then try factors of 4 that would add 2 would not work. So I need to use the quadratic formula for this. So remember, when we use the quadratic formula, we always like to do the discriminant first for b squared minus 4ac. So in this case, this would be 2 squared minus 4 times 4 times 1. Okay, so once I do the math here, I find out that this is equal to negative 12. So then I'm ready to set up my quadratic formula. So I know that x is going to equal to negative b, which would be minus 2, plus or minus the square root of negative 12 all over 2 times 4. So we'll break this down again, negative 2 plus or minus, I'm going to go ahead and do 8. Then we know if we can break this down, I'd have the I on the outside, and this becomes radical 12. Okay, so now can 12 be broken down into perfect squares? So I know this breaks down to 4 times 3. Square root of 4 is 2, so I can break this down to 2, negative 2, plus or minus 2i radical 3 all over 8. Divide everything by 2, and I get x equals negative 1 plus or minus I radical 3 all over 4. So those would be my solutions to this polynomial. Okay, so let's look at another example. Okay, again, I have a binomial. I have two terms and it's a difference. So I see that this is a cubed. Now I need to know if this is a cubed and if a is a cube. So if I think about it, I want to find if a is a perfect square, a perfect cube. So if I think about, I know 3 times 3 is 9, times 3 is 27. So a would be equal to 3x. Because if I multiplied 3x times 3x times 3x, I get 27x cubed. Now 64, I have to think about that. I know the square root of 64 is 8. But if I think about it, I have to multiply the number 3 times to get 64. So I know that if I multiply 4 times 4, I get 16, and multiply it by 16 by 4, I get 64. So I know the cube root of 64 is 4. Alright, so let's look at, remember we know that to break this down, we break this down to a minus b times a squared plus a times b plus b squared. Okay, we're going to have to memorize this form. So I know my a is 3x, my b is 4. So a squared would be 3x times 3x gives me 9x squared. 3x times 4 is plus 12x. And then b squared would be plus 16. Okay, so now I have this factored. Now I want to go and solve it. Alright, so again I would set 3x minus 4 equals 0. Add 4, I wind up with 3x equals 4. Divide by 3, and I get x equals 4/3. Okay, so now this leaves me with this quadratic. Again, I could try to factor it by hand and do 9 times 16 and find factors of that number that adds to give me 12. But in some cases, it's just easier to do the quadratic formula. So I'm going to do the quadratic formula. Remember, we do the discriminant first, b squared minus 4ac. In this case, my b is 12, so I have 12 squared minus 4 times 9 times 16. Okay, so if I do the math, I see that I get negative 432. Wow, that's a big number. So we're going to plug this in. We know that x is equal to negative b, so it'll be negative 12 plus or minus the square root of negative 432 all over 2 times a, which would be 2 times 9. So if I bring this down, negative 12 plus or minus the square root of negative, we can't negative, so I'm going to go ahead and bring that I out. And I'm going to have I times the square root of 432 all over 18. Alright, so now I need to break down 432. Well, with large numbers, the best thing is to do is divide that by 2 and then start looking for perfect squares around that number. So if I divide it 432 by 2, I get that it's 216. So I start looking for perfect squares less than that. So I start with I think perfect square 14 squared is 196. So I would start with that. So I take 432 divided by 196, and that didn't go. And then I would keep going, and I see that if I could break this down, 432 breaks down to 144 times 3. and that 144 is a perfect square. So that breaks down to the square root of 144 times the square root of 3, which gives me 12 radical 3. So this would break down to x equals negative 12 plus or minus 12i radical 3 all over 18. Okay, so then I have to think, can I divide 12, 12, and 18 by something? Well, its largest factor is 6, so if I divide everything by 6, I get x equals negative 2 plus or minus 2i radical 3 all over 3. And then that would be the factors. It would be x plus 1, and then these two here. So those would be our factors for this polynomial. Okay, so I'm going to do one example of the sum of cubes because the work is kind of the same. The only thing different is now I'm adding. Alright, so I need to add. I know that I have a binomial. Both terms are perfect cubes, and this is the form, and you're going to need to memorize this. Alright, so the form is a plus b times a squared minus ab plus b squared. So again, once you identify your a and b, your cubed roots, then all you need to do is plug it back into the form. So let's look at an example. Say I have x cubed plus 125. So I need to know if this a perfect cubed and this a perfect cubed. Well, I know that the cubed root of x cubed is just going to be x and then b. So I know that 5 times 5 gives me 25, multiplied by 5 gives me 125. So b is going to equal 5. So I can rewrite this, and I know this would be like x cubed plus 5 cubed. Alright, so that would be my a, and this is my b. So I just write this out as x plus 5. Then I take a and square it, which would be x squared, minus a times b, which would be minus 5x, and then plus b squared, which would be plus 25. Okay, so now I know that I can, if I want to solve this, I would set it equal to 0. Set this factor equal to 0. I get x equals negative 5. And now I have this quadratic that I need to use the quadratic formula. So if I start b squared minus 4ac and solve, I would put negative 5 squared minus 4 times 1 times 25. Okay, so we do the math, and I get that this is negative 75. So then I wind up using the quadratic formula, x equals negative b, so it would be positive 5 plus or minus the square root of negative 75 all over 2 times 1. Okay, I know I can't have that negative. X equals 5 plus or minus I radical 75 all over 2. Can I break 75 down with a perfect square? And I know that this breaks down to 25 times 3. Square root of 25 is 5, so this is equal to x equals 5 plus or minus 5i radical 3 all over 2. So my solution to this polynomial would be x equals negative 5, x equals 5 plus 5i radical 3 all over 2, and 5 minus 5i radical 3 all over 2, or you could just write it as x equals negative 5 and 5 plus or minus 5i radical 3 all over 2. Either or. These are the same thing. Okay, well that's it for today's notes. We will do some more practice in class tomorrow. Make sure you take notes, do the completion check, and write down any questions you have, and we'll go over it tomorrow. Thanks and have a good night.